Welcome, everybody. This is John Bagnulo with you this afternoon to have an in-depth discussion on the role of the various fatty acids and really where they fit into a healthy diet, how compatible they are with various aspects of human physiology. And I'll say that this talk is not intended to be a webinar on heart disease. However, as I'm sure most of you can understand, the topic of fats and heart disease have become almost inseparable. What I find most interesting about that is it's 50 to 60 years of I guess critical mass early on in terms of what was reported and some of the assumptions that were made, and it's really hard. It's really hard to change a society's perspective on a particular aspect of our diet or nutrition, even though there's just such a compelling quantity of scientific evidence now that really, I think, paints a much clearer picture of the role that fats play in health and disease. And I'll end by saying in this intro that most interesting to me is that fats probably have one of the least influential roles on heart disease, yet that continues to be where most of the discussion lies. So with that being said, Katherine Wohl and I, who will be presenting right after me, we have these 4 objectives for participants today. We really want you to understand the way that fatty acids influence human physiology and some of the cellular organelles. We hope you can identify the most common imbalances with respect to fats. What are those dietary sources and or ingredients that contribute the most significant amounts of specific fatty acids? And lastly, how is it that these fats withstand various aspects of food processing and or temperatures, cooking, etc. So those are our primary objectives today. It's a very still, as I mentioned earlier, it's a pervasive myth that some of these fats have major influential roles on cardiovascular disease or other aspects of health. But there certainly are some clear patterns that science supports that clinically we need to really be on the lookout for. So these are examples of very common fatty acids. Obviously, this does not encompass the entire family of fats, but this would just show what some of the more basic ones look like. I'll start with the monounsaturated fat, oleic acid. I won't belabor this. I know many of you have had this type of exposure somewhere in your education. This omega-9 fatty acid is called omega-9 because, as you see, the double bond occurs immediately after the 9th carbon in this, what are essentially a long chain of carbons with hydrogens. Now, when you get into linoleic acid, that's the second fatty acid down, which is an omega-6 fatty acid. You can see that the first double bond, again, occurs after that 6th carbon. That's why it is an omega-6, and it's polyunsaturated, meaning more than one, of course, because there's 2 double bonds. When you get into alpha-linolenic acid, which is the 3rd fatty acid here, it's an omega-3 because of where that double bond occurs after the 3rd carbon, and so on. And this is really the basics of fatty acid nomenclature. The omega refers to where that first double bond occurs. Mono meaning one, there's only one double bond in the case of oleic acid, which is, again, leading source of that would be olive oil, avocados. Then you can see that the omega-6 fatty acid, linoleic acid, again, it's polyunsaturated because there's more than one double bond. And we move our way into more complex forms of polyunsaturated fats, but I think that this would really illustrate how fatty acids are named and really what the significance of where that double bond occurs. And it does play a huge role in physiology and the production of eicosanoids and cell membrane fluidity and all those different things which we're going to get into in a moment. Here are some of the most common sources of specific fats. Just a quick rundown. Saturated fats are, again, spread across dairy, meat, and all your tropical nuts and oils. There are some unique subclasses of saturated fats, one of which are the short chain fatty acids. These are less than 6 carbons long. Again, they're saturated, there's no double bonds. And those short chain fatty acids, by and large, are produced either by ruminants, animals which graze or browse on fiber, and they are produced within our own gastrointestinal tract by the right families of bacteria. Medium chain fatty acids are those which are between 6 and 12 carbons long. These are the most common, and they are very limited in terms of dietary sources. You know, coconut is made up of around 67 to 72% medium chain fatty acids. You of course have breast milk, which is very rich in medium chain fatty acids because of how critical that is for developing child's brain. And you know, we're learning more about how critical these medium chain fatty acids can be for an adult brain as well, but that'll be on another day that we'll cover that. And then lastly, goat milk. That's also a very significant source. But after those three, you have very, very small amounts in comparison to the amount of fat contributed by other foods. Then we have our more typical dietary saturated fats, which are lauric acid, myristic acid. Palmitic is the one that we predominantly produce in our body when we have high levels of insulin and we go into that anabolic state. And then there's stearic acid, which is widely found in nuts and seeds, and it's in coconut and things like that. A noteworthy saturated fat is the 17 or odd carboned saturated fat, heptadecanoic acid. It's very unique. It's produced also in the rumen, or the lower components of a ruminant's digestive tract. It is very interesting in the fact that it's associated with very great quality of health in populations that have higher levels of this in their tissues. It's also found in certain types of oily fish, but that's an example of a saturated fat that, again, if we're talking about saturated fats, all of these have some wonderful properties and attributes that can really help human health. You know, so I'm putting these together for this initial introduction, but I want everyone that's listening to understand these are all saturated fats, and we can really say good things about all of them when we take a look at human physiology and what some of the science has shown. The next class, which most people are very familiar with, are monounsaturated fats, because that's the one that has been given a very high grade or mark by nutritionists now for 50 or 60 years. We'll get into that in just a moment. It has, again, it's monounsaturated, it has one double bond. Most common form is oleic acid. It's an omega-9 fatty acid, and those are your leading sources, with olives and almonds and avocados being at the top of the list. Now we get into our polyunsaturated fats, which become a little more complicated, given the fact that they can be very long. They can go much longer than 18 carbons. You know, they can go up to as high as 27, 28 carbons long. So those are rare, but certainly DHA and EPA at 25 carbons long are much more common, and those are ones that are well respected because they're found in oily fish. But your omega-6 fatty acids are predominantly contributed by particular types of seeds and or nuts, and we have widespread consumption of these in the United States because of how cheap these oils are. You know, sunflower oil, safflower oil, soybean, canola, and corn oil, they're all byproducts of particular areas of the food industry or agriculture. So while, you know, an agricultural system may rely on the protein from one of these, or the flour, some of that oil is extracted and it's put into either a vegetable oil blend or into the fast food industry. Processed foods tend to contain one or more of these. You know, these are essential fatty acids, but the balance is critical, and we'll look at that in a little while. You do have within these omega-6 fatty acids, you have the linoleic acid, which is in those seed oils, and then you have GLA, which is a little less common. It's found in certain plants. It does have some unique attributes, but it is technically still an omega-6 fat. And then we get into the fully formed or elongated omega-6 fats, such as arachidonic acid, which is found in grain-fed meats, grain-fed dairy products, and the fats of any animal which is predominantly fed the seed oils, which were aforementioned. Then there's the omega-3 fatty acids, which people are always trying to learn more about and understand better. Most people understand that they're associated with less inflammation, and that is by and large true. Those come in two subclasses. You have, for the most part, you have alpha-linolenic acid, which is contributed by things like flax seeds or purslane. It's found in a wide variety of vegetables and plants. It does require conversion by the human body into DHA or EPA for it to be most biologically active. That being said, there are, you know, some interesting papers on whether it be flaxseed oil or foods that are rich in ALA and inflammation, even in the absence of that conversion or elongation to DHA or EPA. But you can find DHA and EPA fully formed in small oily fish, and in larger oily fish, as well as in grass-fed meats and in grass-fed dairy products where the animals are, again, consuming the ALA and their bodies are converting that. So that's a quick rundown on your leading sources of these different types of dietary fats. And what I really hope to convey today, more so than anything, is that it would be an error for any of us to look at these fats solely as the way they influence an individual or a patient's lipid profile. That, unfortunately, to date, has been where the focus really has been. How do these fats and oils influence a person's total cholesterol or their LDL levels? And, you know, like, again, we're going to dive into that in just a moment, because these two topics are, unfortunately, for lack of a better word, inseparable. But I'd like to take a quick look at this illustration, which shows that the presence of specific double bonds in these fats provides it within the phospholipid bilayer. And again, that phospholipid bilayer refers to a cell's membrane, which wraps itself around every one of our, you know, give or take a few billion, trillion cells. You know, we all have a little over 1 trillion cells, and all of these cells contain this phospholipid bilayer, and that phospholipid bilayer is influenced very heavily by the types of fats that we ingest. If our diet is higher in one type of fatty acid, it will be reflected in a very short period of time within that phospholipid bilayer, and it has a huge influence on how that phospholipid bilayer resists things like oxidative stress, how well it allows for conformational changes of the protein channels that lie within this. And that's really important for everything from insulin sensitivity to the export of waste products from the cell. You know, so the highway, so to speak, from the exterior of the cell to the interior of the cell is governed by this phospholipid bilayer, as well as the stability of that bilayer and how fluid or viscous it is. All of these properties are incredibly important to the health of the cell and ultimately to the health of the individual that's comprised of those cells. A saturated fat, which you'll see here in the way of the 16 carbon, no double bond, palmitic acid, you will see that that is very stiff and rigid, whereas the highly polyunsaturated fat with multiple double bonds tends to have significant bends in curvature to it. Now, really, the cliff notes for this discussion are, as I mentioned earlier, a phospholipid bilayer, which is comprised of one type of fatty acid in a predominant type of composition, will take on all of those characteristics. A saturated fat based phospholipid bilayer will be packed together more tightly, will in essence have a higher melting point, which makes total sense when you think about where many of these fats are originating from. If a tropical oil is, you know, coming from an environment where temperatures are above 100 degrees Fahrenheit on a regular basis, we would expect that those plants providing those fats would have a higher melting point to withstand that environmental pressure. The same would be true of the oil found in salmon. We would expect that salmon to benefit from having a lower freezing point, given the type of environment that organism is living within. So whatever fatty acid becomes a major component to the phospholipid bilayer, it will deliver those characteristics to that cell. And, you know, that's very important when we start to look at how it is within human physiology, aspects of our cellular metabolism are influenced by this. Now, as a backdrop to this conversation, I think it's important that everyone understand just briefly the history of saturated fats being vilified by the quote unquote scientific community. This really started with the work of Ansel Keys, who spent time in Italy for the most part and published what was and has been referred to as the 7 countries study, now going back to 1952. It was widely publicized. And, you know, one of the most interesting things about this is that the science, you know, behind it is weak at best. And I certainly mean at best. Yet, you know, if we come full circle now, when we start to look at a time cover here in a much more contemporary light, you know, as I mentioned earlier, scientists are now realizing that saturated fat is not only tolerated in a human health model, but it is very important for, as I just mentioned, certain aspects of our cellular physiology, whether that's a phospholipid bilayer or the health of our mitochondria. And so, you know, the last 60 to 70 years have really been a roller coaster, but I always want people to take a look at, you know, looking at CDC statistics, looking at World Health Organization statistics, which we're going to look at here for the next few minutes. Those first dietary guidelines for Americans, which advised a reduction in fat being replaced by carbohydrates, those, you know, resulted in a spike and a continuous growth pattern here in the area of epidemiology of BMIs and obesity. If we go back to those first guidelines, 1980 roughly, you know, you can see it really, it's no mystery that we have replaced fat with carbohydrates, the wrong types of carbohydrates as well, and along the way have created significant imbalances with fatty acids as well. Now, again, it's important to try to take a look at the role that fats play in human health without being focused on cholesterol. But that being said, I know we're going to have a significant number of participants this afternoon that are still going to have questions around the role of fats in a healthy diet because of what they may have learned regarding cholesterol, again, in the human health model. I would just like to share these next 4 slides with our participants. I have a few other things I think that will also illustrate the lack of association between cholesterol, even LDL cholesterol. At least, you know, when we look at things quantitatively, there are qualitative aspects to an LDL particle that are very important, and that may be a topic for a future webinar conversation. But if we look at total cholesterol, you can see here that there is a decrease in all-cause mortality within the female demographic, and rising levels of serum cholesterol. Now, that's within women. Here's the relationship between serum cholesterol and cardiovascular disease death. Again, you can see that there's certainly not a direct or linear relationship. If anything, there's inverse, very weak R scores or Pearson correlation coefficients. Within men, very similar numbers. So what these slides are illustrating, these are World Health Organization data, statistics, and how they relate to all-cause mortality or mortality from cardiovascular disease. And there just is, statistically, there is no association here. If anything, higher levels of cholesterol may in fact be protective. Now, these do not stand on their own. So I'm going to take things in a chronicle fashion. I want to go back to 2010. You know, we're talking a decade now. This was one of the studies or investigations that really started to provide a reversal in the policies, public health policies and guidelines being set forth for different populations. By the way, I think everybody should know that Australia and New Zealand have totally reversed their dietary guidelines, and they have now advised that their populations eat eggs as well as eat full-fat dairy products. And again, this study over 10 years old showed that you can just get a quick appreciation for this. You can see that there is, with the highest tertile of full-fat dairy, you have the absolute lowest risk for cardiovascular disease. This has also been shown for all-cause mortality. So high-fat dairy, protective, low-fat dairy, or an absence of dairy fat, you have basically a hazard ratio of 1.0. So this is 10 years old. Now we're going to look at what I consider to be a landmark paper, one that I refer to often when I give talks in educational sessions. This is the PURE study, which had a massive N value, massive number of participants, 5 continents, 18 different countries, a wide variety of cultures were represented in this. And saturated fat had an inverse association with risk for stroke. And it was very clear that higher levels of dietary fat resulted in lower all-cause mortality, and carbohydrates were associated. Increased levels of dietary carbohydrate were associated with higher risk for total mortality. Again, this is, I think, a very high quality epidemiological investigation. I encourage everybody to take a look at this paper. It's free online for anybody that's interested. It is the PURE study. Now it's just a little over 2 years old. These are some relationships that were found in the PURE study. You can see that when you look at the percentage of energy coming from different macronutrients or classes of fats, you can see that monounsaturated fat, interestingly enough, has just a steady decrease. The more monounsaturated fat in the diet, the lower the relative risk. Saturated fat as well, and the same is going to be true to a lesser extent for polyunsaturated fat. Polyunsaturated fat was the only one that had any type of association negative, which is where when polyunsaturated fat became a much larger percentage of a population's diet, it did produce a slightly increased risk for stroke, and we can get into why that may be the case. But again, this is all in chronological order. Next would be a British Medical Journal paper which showed a lack of association between LDL cholesterol and all-cause mortality. And again, the findings here suggest that higher levels of LDL are protective in the elderly, at least. And again, large number of studies were looked at in this, and it really illustrated higher levels of LDL, not total cholesterol. That again, that would certainly could be indicated as well, but LDL, which is usually associated as the more harmful type of lipid, but in the elderly, higher LDLs had lower all-cause mortality. And this does not stand alone. This is one of now several papers illustrating the same type of relationship. Here, we're going to look at hyperlipidemia. These are people that have levels of cholesterol greater than 200 milligrams per deciliter, which we would, I think probably most participants today and most clinicians, if you ask them, would say, well, that's certainly going to be associated with higher risk for myocardial infarction or some kind of decompensation within cardiac tissue. But if you take a look at this, you can see that there's actually a protective effect with higher levels of total cholesterol, i.e. hyperlipidemia, against both this decompensation in cardiac tissue as well as acute myocardial infarction. So there's actually a reduction in risk with higher levels of total cholesterol. And this is, for many people, I know this is going to take time to sink in. It is going to really raise serious questions, and I would expect that. But then we can take a look at heart stats. This is well-publicized data looking globally at populations and looking at studies within those populations and showing that there is this U-shaped curve with respect to all-cause mortality and total cholesterol levels, and that sweet spot is going to be somewhere between 210 and 230 milligrams per deciliter. Certainly not under 200, which is unfortunately the guidelines that many people are operating off of. So this is all bringing into question our policy clinically, what our goals should be for patients, as well as, and related to today's topic, how we look at fats. Now, cholesterol comes in a wide variety of forms, and it is critical for the production of androgens. Those are commonly known as your sex hormones, such as estrogen, testosterone, and many of the precursors to those. And cholesterol can be sulfated, which makes it water soluble, but not having adequate cholesterol can really undermine specific tissues in the human body. We know that there's a relationship between lower cholesterol levels in skeletal muscular as well as cardiac muscle pathologies. That's why many patients that go on statins are advised to take something like CoQ10 to try to offer some level of protection in the absence of the desperately needed cholesterol in those tissues. But there are other tissues in the body, especially the brain and the central nervous system, which rely very heavily on higher levels of cholesterol. So again, cholesterol is unlikely the enemy. It's what ultimately happens to that cholesterol, whether or not it's oxidized, how it's packaged in the body when it leaves the liver. And, most fundamental to this discussion, as well as the discussion around fats, it comes back once again to this phospholipid bilayer. This is the fundamental unit that encompasses all of our cells and is ultimately responsible for how metabolically effective and or efficient that cell is, how resistant it is to free radicals and oxidative stress, and how easily it can undergo these what we call conformational changes to allow molecules to enter the cell and substances to exit it. And this is controlled by both cholesterol as well as specific fatty acids. Now, it shouldn't be a surprise to us that the diet has not only room for saturated and monounsaturated fat, but that it would call for it. And there's endless examples throughout the natural world and in human history that would point us in this direction. We can look at mammals and our most closely related mammals, and we can see their diets are always, somewhere between 50 and 58, 60% saturated and monounsaturated fat. And that's certainly the case with the typical more natural diet of a gorilla, where they're foraging on leaves, and then their lower digestive tract is converting all of that fiber to short chain fatty acids, both saturated and monounsaturated fat. So that's the transformation we're referring to here. You can look at human breast milk. You can look at, which is, again, largely saturated and monounsaturated fat. You can look at ancestral diets when populations were not given any type of dietary guidelines, and they were left to their own means of trying to nourish themselves or their population. Everything really shows that saturated and monounsaturated fats have that higher level of what we call biological compatibility. Monounsaturated fats, the good news is that for people who appreciate olive oil and maybe, really are only aware of populations that rely on that as a type of fat or oil and have better levels of health, whether we're looking at Greek populations or islands like the island of Crete, throughout the Mediterranean, we know that the olive and olive oil has played a pivotal role in that diet and may be responsible for many of the health attributes of that Mediterranean diet. But certainly monounsaturated fats are some common ground that exists. And, I think that's favorable to have a significant number of our clinicians appreciate monounsaturated fat, because it is very compatible. And as I've showed earlier, there's a downward sloping curve for higher levels of monounsaturated fat and a reduction in all-cause mortality, whether we're using hazard ratios, relative risk. It's clearly protective at even very high levels. And there are populations within the Mediterranean region, for instance, that get more than 50% of their calories from olive oil, and they have excellent quality of life and very low risk for chronic disease and any type of inflammatory disease. So this is a very recent paper. This is a paper that I would encourage all of our participants to look at. It came out just a month or so ago. And again, we can make these slides available to those that are interested. Now, why is it that monounsaturated fats are so much more compatible, let's say, with human physiology, and why are they probably tolerated at the greatest level? But I would say that saturated fat is also tolerated at a very high level. But that aside, a lot of it has to do with the role of specific fats in tissues within the body where there are very high levels of free radicals being generated and oxidative stress. And that's the case within the mitochondrial membrane. All of the energy that the human body produces is generated within the mitochondria. When that takes place as a byproduct of what we call metabolism and oxidative metabolism, what we generate are these free radicals that can be very damaging to more polyunsaturated fats and can be very damaging to the membrane as a whole if the remodeling process is not supported. So this is that mitochondrial membrane, and the paper, which I encourage everyone to look at, looks at cardiolipin. Cardiolipin is an integral component of mitochondrial membrane stability. So a mitochondria can't function as effectively if it doesn't have this adequate level of cardiolipin remodeling, which ultimately allows that membrane to make changes, to adjust and compensate for higher levels of oxidative stress, and to keep mitochondria producing energy to support the needs of a cell. And we know that this is really important when it comes to neurological health as we get older. And in fact, cardiolipin remodeling and its role in mitochondrial health is being shown now to possibly be the greatest determinant or risk factor for the neurodegenerative diseases. We know that cardiolipin remodeling is compromised by gut disorders or dysbiosis, and it's also compromised by having the wrong types of fatty acids and over an overrepresentation, I would say, of your omega-6 polyunsaturated fats and not having enough of the saturated and monounsaturated fats. Because when we look at that, you can take a look at this slide. This is looking at cardiolipin remodeling within the mitochondria. It's very technical, but I think it illustrates that in the upper left-hand corner of this slide, which is example A, you can see it has the fewest number of red dots, and that suggests in this particular study that the use of olive oil supported a much more healthy and balanced level of cardiolipin remodeling. It was much more effective without major changes. And the more you go to a higher concentration of red dots, then the less stable that mitochondrial membrane ends up being. Now, again, why is it we've been told to cut out saturated fat and go in favor of a highly polyunsaturated fat, omega-6 rich diet? A lot of this had to do with not only the work of Ansel Keys in 1952, but also on this, really myopic focus on what's happening to a population's cholesterol levels, or a trial group's cholesterol levels when you substituted saturated fat with, let's say, an omega-6 rich oil. This is an excellent paper. Now it's 3 years old in the Journal of Nutrition, which showed how poor much of those controlled trials were, and they were, for the most part, inadequately controlled. And when we take that into account, you can see that the control group, those who were having the diet still high in saturated fat, saturated fat was not being replaced by seed oil rich in omega-6s, that the trial actually favored the control group. And it's only in your inadequately controlled trials where the omega-6 or the intervention arm saw benefits. Now, I think this really shows that it's a combination of misinformation that has been put forth over these last several decades, poorly designed and poorly interpreted, these clinical trials, as well as a foundation that was weak at best to begin with, and also, more importantly, a lack of appreciation for the role that different fatty acids play in human physiology. Now we're at a point, and this is going on based on CDC and NHANES data. If we go every 10 years or so, you can see that we have more linoleic acid in biopsy samples from US citizens than ever before. The levels are, 4 to 5 times what they were back in the 1960s, pre-dietary guidelines. So what are the ramifications of that? How has this contributed to inflammation and imbalance? Well, again, I don't want this to be limited solely to the icosanoid or inflammatory pathway. I mean, it'd be very easy to look at the role of omega-6s in pathology as simply an excessive pool of inflammatory substrates to build upon, but that's not really the whole story. The story also goes into that phospholipid bilayer and how these omega-6s can lend themselves to a less stable mitochondrial membrane or phospholipid bilayer. So that's part of the story, but they certainly do play a big role in the production of icosanoids of the series 2, which you're going to see here on the left. And the omega-6s are cleaved off by a cyclooxygenase enzyme. That's why many of the anti-inflammatory drugs have these COX inhibitory components. COX inhibitory components are going to block the activity of that cyclooxygenase, and that prevents the formation of these prostaglandins and thromboxanes of the series 2 variety, which cause inflammation and can increase platelet aggregation or likely clot formation. And they also, this is very important, they decrease vasodilation. So that's where their relationship to hypertension comes in. On the other side of that, you can see the omega-3s, they have, for the most part, they have counter roles in that. They improve vasodilation, they tend to prevent clots from forming, and they are anti-inflammatory. Now, that being said, they're both critical, they're both essential fatty acids, but balance is really, I think, the take-home message here. You need to have a specific amount of omega-6s as well as omega-3s in the diet on a regular basis, but balance is the critical component to that discussion. Now, as I mentioned earlier, the linoleic acid has to be elongated to get into a form that can be ultimately used for the production of some of these thromboxanes and other icosanoids. Same is true of the omega-3s. They need to be elongated The rate of conversion in a human population varies based on age and sex of that particular population. You know, women between the ages of 15 and 45 tend to convert omega-3s from an ALA form to either DHA or EPA, somewhere around 20%. Those numbers vary depending on the research you look at. For men, it can be much lower, again, depending on their age. And there are genetic components to this as well. So it's not to say that everybody is going to convert the omega-6 oil, rich oil, or the omega-3 rich oil at the same level, but those are, for most of us, those are the primary building blocks we're going to start with. Of course, if you eat oily fish, you're going to get the DHA and EPA in a fully formed fashion, as well as if you were to eat, let's say, poultry for that matter, the fat from poultry is going to be very high in arachidonic acid. It'll be fully formed, typical of a typical poultry diet, which is often very rich in corn and soybeans. So that, just kind of gives us an overview of what's necessary to elongate and desaturate some of these more basic omega-6 and omega-3s. But when they get to that final point of either arachidonic acid or a metabolite after that, certainly the case of DHA, they have some very unique influences on tissues, again, going far beyond the circulatory system, the cardiovascular system. The human brain is heavily influenced by the presence of these different omega-3 and omega-6 metabolites. And those are now being referred to as pro-resolving mediators or pro-inflammatory mediators. And obviously for brain health, we're trying to really minimize an abundance of pro-inflammatory mediators. We know that the inflammatory process is affecting the human brain now in our society, in our population, in a very, very large number of people. And it is also responsible for, widespread neurological imbalances and pathologies. And so inflammation has been a hot topic, and we know that the type of dietary fat in the population's diet plays a huge role in that. Arachidonic acid, as I mentioned earlier, plays a role in hypertension and inflammation, but it also, the cytochrome P450 series, those are your enzymes that are needed for detoxification. They actually are called upon to take arachidonic acid to other metabolites. So it is, it goes beyond just being a fat that can play a role in physiology or in inflammation. Arachidonic acid also requires liver enzymes and detoxification pathways to be processed in a compatible fashion for human physiology. Here are just some quick pictures in terms of what the omega-6 and omega-3 content looks like for specific oils or plant oils. You can see that it ranges from safflower oil, which has the highest omega-6 content and almost no omega-3, down to flaxseed oil, which is the antithesis of that. Basically, it's very high in omega-3 fatty acids and it's very low in omega-6s. And I think what's important here is that, the data, conservative estimates are that somewhere around 30-1 omega-6 to omega-3 United States in terms of average dietary ratios of omega-6 to omega-3. 3-1 is what most anthropological research and experts would suggest our ancestors ate. 1-1 may be what's required to reduce or reverse an inflammatory process. So these are some ratios of clinical significance. Now, I've just briefly given you an overview here of the roles that they play. We've talked a little bit about some of the research that has been done in the past. And I just want to give you these epidemiological observations or relationships between highly unsaturated fatty acid levels in tissue. This is research that is relying on biopsy samples and looking at the fatty acid composition of those. And you can see that higher levels of the omega-6 fatty acids in various populations increases mortality. And when you take a look at the relationship of omega-3s, and again, looking at tissue concentrations, you have this inverse relationship, again, between cardiovascular disease mortality. There's that inverse relationship between that and omega-3 content in the tissues. And more recently, this paper looked at the role of, and again, using quartile type research, EPA and DHA, fully elongated omega-3s, looking at the levels of those, where they were, and then looking at levels of linoleic acid, which is again, the basic omega-6 fat that's contributed by most of your industrial seed oils and those vegetable oil type blends, you can see that when you have the lowest level of linoleic acid and the highest level of EPA and DHA, you have the least amount of this tumor necrosis factor, R2 and R1. These are inflammatory markers. Same has been shown with C-reactive protein. When you have the highest levels of linoleic acid, which is in the back corner, and you have the lowest levels of EPA and DHA, again, this would represent the greatest imbalance between omega-6s and omega-3s. You have the highest level of inflammation. So it's what we'd expect based on everything that's been observed, both in the lab as well as in epidemiological studies. And with that, I want to, before I turn this over to Katherine, I just want to highlight a couple very important points here that I've tried to convey. Saturated fats and monounsaturated fats have the greatest ceiling for biological compatibility. Therefore, they need to make up the greatest amount of fat in our diet. That's going to vary from person to person in terms of how it's tolerated based on a person's digestive capacity, whether or not they have a gallbladder, whether or not they have, higher levels of pancreatic lipase, or all these different factors. But it should be the fat for most humans that contributes the largest amount of calories to one's diet. Saturated fats and monounsaturated fats, because they have either no or just one double bond in the case of monounsaturated fats, are less susceptible to oxidation. Therefore, by and large, they hold up to higher temperatures. All types of things have been reported about olive oil and cooking, but when you go look under, the Journal of Agriculture and Food Chemistry, you look at the research at places like UC Davis, what they've shown is that olive oil stands up to temperatures of like 350 degrees Fahrenheit for hours on end. It is very resistant to oxidation, even though it may not be as resistant as something like coconut oil or avocado oil. It is, because it's largely monounsaturated, far more resistant to oxidation than a highly polyunsaturated oil, which has all those double bonds that can react with oxygen, especially in the presence of heat. I think people should consume at least 1,000 milligrams of omega-3s a day. These numbers may vary, but it's going to be more than anything a function of a person's age, what level of development they're in, as well as the levels of omega-6s in their diet. Again, keep omega-6s, keep them limited. We need them in small amounts, but the amount we get from eating whole nuts and seeds or eating things like avocados is going to be more than enough to provide those essential levels of omega-6 fatty acids. Aim for ratios of 3 to 1 for young children who are still developing, 2 to 1 or less for adults. You may require a 1 to 1 ratio for someone with higher levels of inflammation. And with those patients who have some level of chronic inflammation, it may be very beneficial as a clinician to request an omega index type test, which is going to look at typically red blood cell membranes, analyzing those for their omega-6 to omega-3 fatty acid levels. So with that, I really thank you for your attention to this. I look forward to trying to answer your questions in a moment, and I want to turn it over to Katherine.
Thank you, John, for that great review. I'm just going to go ahead, and you can see my screen okay?
Yes.
Okay, so my goal is just to expand somewhat on what John presented and really highlight some of the clinical takeaways that you can use when applying these concepts for your patients or the clients that you're working with. So as John mentioned, I think it is a topic that is really still not very well understood, among healthcare practitioners. And then if you translate that to the patients that you're working with, it's even more, can be really misunderstood. So I think it's important for us to be educated as well as know some of the main takeaways, because this research is incredible and fascinating, but if we can't translate that into who we work with, it will be benefiting us, but not the larger population. So it'll just be a few minutes, and what I really chose to highlight, what I chose to highlight was really the questions that I specifically get when I work with patients and clients that tend to come up over and over. So really, when we're looking at who can this possibly benefit, and John highlighted so many, and really it's it can be really all-encompassing because it can apply to people with really mild symptoms to more significant conditions. So John was just mentioning inflammatory conditions, which, most of the people that we work with, there's some level of inflammation, especially with such a high imbalance that's happening. Just correcting small things can make such a big difference. Blood sugar imbalance, that I think too is, it can go from mild. You have someone that is, struggling with energy or daytime fatigue related to those blood sugar crashes because maybe they are really doing protein and vegetables and not being satiated and not really, including more refined carbohydrate, and there's nothing to kind of balance that out. So simple changes in balancing that blood sugar curve to really where that is also included in more significant conditions related to insulin resistance and how chronic insulin resistance can also contribute to inflammation. So many of these things are linked together. Limited intake and early satiety. So I work a lot with people that can't maintain oral intake. They can't eat large volumes of food. And so fat is a really beautiful thing to include especially if they don't have any issues digesting it, because you can get a lot of bang for your buck. And just, I think, simply explaining, how much nutrition and how much caloric density and nutrient density can be in something like olive oil or an avocado can really be encouraging for them, and really simple to add more of it to their foods and take away some of the fear that they might have around adding more of it. Metabolic syndrome, diabetes, cardiovascular disease linked to inflammation, as well as blood sugar imbalance, as John talked about, and then mitochondrial disorders and neurodegenerative conditions. I think those can be, again, more of the significant areas that show a lot of promise. And maybe you are not only encouraging more fat, but limiting the carbohydrates, perhaps moving to more of a ketogenic type nutrition plan and implementing for those patients as well. So education surrounding this topic can benefit most of the people we work with. And I think, I don't mean that, there's never a place to educate on lower fat. And I know that people see conditions or there's trouble digesting. But if that is the case and the few that might be present, then you really want to educate people on, what types they're choosing, maximizing the types they are, how to cook with those oils. I think there's so much, again, that's misunderstood, that there's the topics that we can clarify so that the fats that you're choosing do promote that anti-inflammatory state and they don't promote more inflammation. So again, with this, I think, John highlighted so many reasons it's important, but really getting clear on the importance of quality fat. So I think the messaging around healthy fat and including it, I think is out there. And I think a lot of people have started to embrace that. I think less so surrounding saturated fat, but all around, healthy fat as part of a diet is out there. And I think most people are like, yeah, the right kind of fat. But I also find, even if it's thought about, the fear of fat that they might have is so deep that it's still really hard to kind of add those foods to your diet. And like I said, the blood sugar imbalance that you might see, or early poor satiety and not feeling full with meals, because we've been taught for so long that fat is bad and the messaging around fat. I think full fat dairy is a great example. It can be really, really hard to kind of communicate to switch that there's benefits to including the fat, again, because the calorie messaging is so strong. So reviewing the importance of quality fat and its ability to help the absorption or importance of absorption for fat-soluble vitamins, helping to create a strong immune system. As John mentioned, the importance in maintaining healthy cell membranes and cell signaling. It's essential for brain health, essential for balanced blood sugar, and increases satiety between meals. So this is something I really tend to focus on again. So I think reviewing the importance of quality fat, but also really linking that to what's specific for the client or the patient that you're working with. So there's a lot of reasons it's beneficial, there's a lot of research, but what is the connection to them that would really click and get onto this messaging and not be as fearful to include it. And then the next step is always which quality fats and oils to emphasize. So healthy fats and oils, olive oil, I think it has the health halo around it. It's the beautiful one that everyone can tend to agree on. Avocado oil, coconut oil, flax oil, ghee, and grass-fed butter are the ones I really tend to highlight, especially olive, coconut, ghee or grass-fed butter, and we'll get to the cooking, using those in cooking as well. And then nuts and seeds, especially macadamia, cashews, hazelnuts, those ones that are especially, you know, as John mentioned, lower in the omega-6 content, just because we tend to get those so easily. Avocados, which again, kind of like olive oil, have a big health halo around them, and with good reason. They're really rich in good healthy fats, and then also deliver great fiber as well. And then focusing on quality protein, John mentioned, you know, chicken. So grass-fed meat, you know, really aiming for quality protein, what the animal eats matters into the consumption or what we get from that animal. Cold water fatty fish like salmon, mackerel, sardines, and pasture-raised eggs will have more of the right type of fat content that we're looking at compared to poorer quality or more poor quality versions of those foods. And then what do we remove? And I think we've highlighted this quite a bit, but especially the industrial seed oils, including corn, soybean, sunflower, safflower, canola. There's other areas, you know, again, we can focus on poor quality meats versus very quality meats and the differences that exist. But especially, I think that even if you are not cooking with these things or they're not in your cupboard, they're so easy to get into the foods, the packaged foods that we consume, going out to eat or relying on going out to eat quite a bit will also get you these. There's very few restaurants that cook with some of the better oils, so they sneak in regardless of if you're cooking with them or not. So some of the main tips and questions that I get as the last slide here that I'll focus on. So again, cooking with fats and oils, John mentioned this, but I think one of the biggest questions things I have to clarify is around, you know, what oils are appropriate to cook with. And olive oil is the one I would say that, yes, I think 350 and below is what I typically recommend. But so many people, you know, are around olive oil being good, and then they're taking, you know, their wonderful vegetables, broccoli, Brussels sprouts, sweet potatoes, dousing in good olive oil, then cooking at like 450 or 425. And they're trying to do really great things, and it's a simple thing that you can correct and say that's great, but maybe sub it out with one of these these higher heat, they're able to withstand higher heat. So coconut oil, grass-fed butter, ghee, and avocado oil tend to be the best. And then low to medium heat olive oil, and then also great for dressing or finishing. And then flax oil as well is something for no heat that you can use and offer a different oil. So I think it's especially great to get your foundation of the oils that you use. And, you know, I think coconut and olive are two great ones, and then expanding, but I think less focus on, you know, the 20 different oils that, you know, can be overwhelming, and most of them are not great for your health. Sourcing is important. So many are probably aware too, olive oil is something that is great, but it can be often mixed with other types of oils to make it less expensive. It can be sourced from many different areas. And so olive oil is, you know, we see in all the studies, it's health promoting, it's wonderful, it has the great polyphenolics, but that's the case when you're sourcing it well. And so cold pressed or extra virgin will maintain that you have those beneficial compounds, and also that it's not going through any processing, which can potentially create toxic products within that oil. So again, when we're trying to do good things for our health, we have to sometimes, unfortunately, look beyond what's right in front of us and dig a little deeper, because so many of these foods that have health halos are now being produced in less healthful ways. So especially if you can source olive oil from a single estate, that'll ensure better processing and better care of that olive oil. And then animal products, looking again for grass-fed, pasture-raised, wild fish, those will have better omega-3 profiles or better fatty acid profiles. And then read the ingredients. I think this is so important. I would say second to cooking with fats and oils is the question I get, or even if you think you're not having that, you can look at many different foods that have these oils included, from hummus to nut butters, which are looked at as really healthy. But if you're purchasing most of your foods from the grocery store, it can be really hard to find a hummus that's made with olive oil. So making sure, you're reading ingredients and educating people on how to look for things, and enteral formulas as well. It's really hard to find enteral formulas that are created with the type of oils that are most beneficial for our health. And then I know I'm preaching to the choir as far as this last note, and we'll get to your questions, but educate in terms of the whole diet instead of just one macronutrient. So we focused on fatty acids, and I think it's a really important topic, but of course, we want to include that olive oil. We want to saute vegetables in coconut oil, and we want to have that with good quality eggs and good quality protein. So a lot of times, if one study comes out about coconut oil, then I think people jump on that, and that's the only oil they're using. But what we look for is a really broad nutrition plan and a really broad diet that has the right things, but also variety in the setting of ample vegetables, quality protein, low fructose, the right kind of fruit when you're including, so complex carbohydrates. So that's also really important, is to make sure that you're encouraging variety with the patients that you're working with. So that will conclude our formal presentation. For those of you that are not aware, Functional Formularies does have 2 new products. They have a new peptide formula as well as a new ketogenic formula. So to highlight some of the attributes, of course, with all other Functional Formularies products, they are organic, sourced from the highest quality ingredients. They are made with the peptides hydrolyzed pea protein and coconut MCT oil. The peptide is nutritionally complete, and speaking of fats, the omega ratio is really quality in these products. So feel free to email sample@functionalformularies.com to try the new peptide formulas or the new keto products, and they'd be happy to help get you started with that. So I know we're close on time. If you don't mind going a few minutes over, John, I will focus on get to some of these questions. Okay. All right. So, John, is it okay if we spend a few extra minutes?
Yeah, absolutely.
Okay. So, there are quite a few. So, can you speak to TMAO and cardiovascular disease and brain effects?
Yeah, sure. Trimethylamine oxidase is a pro-oxidant that is produced by certain types of dysbioses, which are imbalances of gut flora. Most of the research to date has come out of Cleveland Clinic, which has shown that within certain patterns of dysbiosis, if someone eats a rich source of carnitine or a rich source of choline, that the gut flora will metabolize those particular nutrients into this TMAO, and it is, it does oxidize LDL, so that would be its role, in the development of cardiovascular disease. And it has been, I guess it has been at least postulated, there isn't a lot of data on this yet, that it can also have pro-oxidative effects on the brain. But it's not a completely understood story yet, because some of the highest levels of TMAO are found in things like fish. Fish have very high levels of TMAO, and yet we know that having fish twice a week tends to be associated with much higher levels of health and lower risk for all-cause mortality. So I don't know as we fully understand TMAO, and I certainly wouldn't want to have anybody avoid the consumption of choline-rich foods like eggs or carnitine based solely on that. Again, I think there's a lot we're going to learn about it, but it is more a function of gut flora, because in people who had healthy levels of gut flora and ate more vegetable fiber, you did not see in that research at Cleveland Clinic, you did not see the TMAO response.
Thank you. And going back to the PEER study, can you address limitations as far as looking at total carbohydrates and didn't separate into refined versus unrefined, and didn't assess trans fat intake, and did not look at substituting polyunsaturated fatty acids for saturated fatty acids, and how they impacted mortality?
Yeah, I mean, I can, just for the sake of time here, I'll say that study, if a person's interested and they really look at that study closely, they will see the details which are there. It is the slides I showed. I mean, I'm limited in terms of time I can present here to this group, but the study was excellent. So many different components of lifestyle were controlled for to the best of advantage. And that 2020 paper that I referenced that looked at the relationship of fats and carbohydrates to all-cause mortality, it was almost like a build-off of the PEER study. They did look at the difference between sugar and starch. Those things have been accounted for. And within that PEER study, carbohydrates, sugars, and starches, as they started to become a larger and larger percentage of the diet, they did result in higher risk for all-cause mortality. So that's there. I would encourage anyone interested to look more closely at that.
Okay, and there's probably several big questions in here, and so again, as I always, maybe there's another webinar that we do in the future, but can you speak to supplementing with omega-3s versus obtaining them from your food sources?
I would be in favor of obtaining them from food sources, so long as food sources that contain omega-3s are represented in an individual's diet. What I'm saying is that the research around fish oil has a significant number of questions around it. Not only is there any efficacy to it, but at what point does that fish oil maybe start to work against a person's physiology? So I am not convinced that taking fish oil is the way to go. I think it'd be much better for people to eat fish a few times a week. I think, again, you can get these omega-3s from other things other than fish, whether that be flax oil or that be grass-fed meat. But I'm always one to try to rely on food first, whole foods first. So I would be much more in favor of that based on, a variety of studies I've looked at.
Okay. There's a question on roasting vegetables with olive oil due to a high temperature. So I typically recommend, if you're going to use olive oil in cooking, 350 and below. Is that typically what you use, John?
Yeah, I mean, olive oil will hold up to 350. The paper that I referenced that was in the Journal of Agriculture and Food Chemistry showed that olive oil held up to 350 Fahrenheit for 30 hours, which obviously no one's going to roast their vegetables for that duration of time. But I think you're fine with olive oil at 350 or less. I think you could also use avocado oil, olive oil, depends on, the preference. Certainly coconut oil would be very safe, and butter holds up at that temperature as well.
Can you clarify recommending consumption of poultry skin due to the arachidonic acid content?
I would not advise eating poultry skin based solely on the arachidonic acid content, as well as the levels of advanced glycosylated end products. These are cross-links that form between this tiny amount of carbohydrate in poultry skin and the proteins and the fats there. When that chicken is baked, even at modest temperatures, you form these cross-links known as age molecules, and they are something that we want to avoid as much as possible. So for that, I would avoid it. Now, if that entire chicken were thrown into a soup or a stew and that were simmered, I think that there's much more compatibility for that chicken skin with a healthy human physiology. But I would definitely advise against eating fried, baked, or chicken skin cooked at higher temperatures.
Okay, and a question on cholesterol. Since we make our own bodily cholesterol, isn't it unnecessary to consume it dietarily? My understanding is that when we consume saturated fats, they are converted to cholesterol as needed. Anything dietarily consumed could end up being extra and contribute to overload, or it could cause our liver to underproduce in an effort to regulate the levels. Is that true?
No, that's not true. All the research on cholesterol consumption, and there are now, a very large number of studies have shown dietary cholesterol, whether that be from eggs or from meat, it really has, for the most part, very little to no influence on cholesterol levels. In fact, many of these cholesterol-rich foods, like eggs, shellfish, are actually associated with very favorable micronutrients that accompany those foods, and the frequency of them, right? Especially with eggs now. I mean, egg consumption eggs have not only been vindicated, they're being advised that people eat them because of some of the papers coming out of places like Japan, Australia, which I mentioned. So no, I have no concerns with dietary cholesterol. Now, I do have concerns with dietary cholesterol that is oxidized. That's an entirely different story. That's called, or referred to as, an oxysterol. That would be in the way of something like powdered milk, some of your dairy products, which are heavily processed and exposed to oxidation. Those can contain high levels of oxysterols, and those are very deleterious to human health. So I'm against the consumption of that. But the cholesterol that comes in a soft-boiled, hard-boiled egg, I think it's really a non-factor.
Okay, and then maybe I'll just try to hit some of the quicker questions. But are walnuts a good option for nuts and seeds?
They're not that great. They do contain some of the alpha-linolenic acid, but they do have higher levels of omega-6s. Flax seeds and flaxseed oil are going to be a much better source of omega-3s without the omega-6s. That being said, having a few walnuts a day would be well tolerated and could certainly contribute to someone's omega-3 intake or their alpha-linolenic acid. It's a nut or seed you'd want to be, I think, really modest with in terms of consumption. I know the late James Joseph, who was at the USDA Tufts Laboratory on Aging, showed that in animal studies, when walnuts went from 1% of an animal's diet to 3% of an animal's diet, the animals not only failed to experience any benefits, but they started to die at a much younger age and had much higher levels of all-cause mortality. And that really, I think, illustrates that there's a ceiling for some of these omega-6 rich nuts and seeds, and walnuts are certainly in that category. And when they start to become too large of a percentage of our calories, then it creates imbalances in our tissues, like I mentioned, with the phospholipid bilayer. So I think walnuts can be enjoyed in small to modest quantities, but it wouldn't be something that I think people would want to eat larger quantities of.
Okay, and out of respect for time, I will just ask one last question. Is science pointing to low carb and keto as having the most benefit for long-term health?
I would say that, we could probably go a little broader than that. I think there are definitely signs that indicate carbohydrate restriction. Now, whether we want to call that restriction to be 30, maybe as much as 40% of calories, or we want that restriction to come all the way down to a ketogenic level of 5% of calories. I don't think at this time we have empirical data to suggest that 5% of calories coming from carbohydrate across all human populations is necessarily better than 30% of calories from carbohydrate. But yes, I think in light of how most people eat today, which is where 60% or in some cases 70% of calories come from carbohydrate, yes, I would answer that question by saying yes. I think there is clear evidence that at least some carbohydrate restriction, how rigid that is would be on the way people interpret the data, but certainly I would choose 30% of calories from carbohydrate as that sweet spot that I'd feel very confident in saying serves most well. I think there is clear indication from all scientific data that that is the way to go, and it has numerous benefits on human physiology and on health.
All right, well, I think that's a great one to end on. Dietitians, I will be sending the certificate for attending and by the end of the day, so please be on the lookout for that. And and we are grateful for all of you joining us today. Anything to end, John?
No, thank you so much, Katherine, for what you shared with us and for putting this together. And I want to thank all our participants for their interest in those questions. And I look forward to meeting everybody next time. Hopefully we can do this again soon.
All right, thank you. Have a great day, everyone.